Hello students. In this video, we will start with Module 5 topics, Truth Values and Tables. First, let us see about linguistic variable. We have already studied fuzzy logic uses linguistic variable. For example, we can say age as a linguistic variable if it have values like young, very old, like that, instead of having a precise numeric values for age. So the values of the linguistic variables are words or sentences in natural language instead of the precise numeric values, and it provides an approximate characterization of a complex problem because it gives a clear characterization. The name of the variable, universe of disclosure, and a fuzzy subset will characterize a particular fuzzy variable. And the linguistic variable is characterized by name of that variable. Let us take it as x, and it will have a term set of the variable t of x, and there will be some syntactic rule for generating the values of the linguistic variable and a semantic rule for associating all the values generated using the syntactic rule with a particular meaning. The other term is linguistic hedges or modifiers. Let us see an example. We have a fuzzy set, and in that set we are having a linguistic variable very tall, and this linguistic variable is having a modifier, that is the tall is modified by the word very, and this very is called the linguistic hedge or the modifier of that particular linguistic variable. Now let us see about reasoning and proposition. Reasoning will have a logic, and that logic is the basic of reasoning. But proposition means it is simple text sentences in any of the languages. And this proposition is expressed in canonical form as Z is P, where this Z is a subject and P is the predicate. Predicate means something which defines or characterizes the subject. So Z is P is the expression for proposition, and Z is the subject and P is the predicate which defines the characteristics of that particular subject. Let us consider one example. I had written a proposition which is the normal text sentence in any language. So this is the proposition. London is in United Kingdom. So here the normal representation is Z is P. So London is in United Kingdom. So London will be the subject and in United Kingdom is the predicate. So this predicate specifies the property of the subject. That means in United Kingdom specifies the property of London, that is its geographical location in United Kingdom. Also, every proposition will have an opposite called negation. Now let us see truth tables. Truth table is a representation which defines the logic functions between two propositions. For example, we take two propositions x and y. X can be either true or false. Similarly, y can also have values of true or false. So, the logic function, this truth table will define the logic functions between the proposition x and y. And some of the basic logic operations performed on the propositions are: first one is conjunction, which is the AND operation. Next is disjunction or operation, implication or conditional, if X then Y. And bidirectional or equivalence, X will be true if and only if Y is also true. Consider this truth table. X and Y are two propositions and it is having values, a combination of values like true and true, true and false, false and true, false and false. So the conjunction operation, that is AND operation, will provide true only if both the propositions are true, else it will be false. And in the disjunction, that is OR operation, it will be true if either of the proposition is true, and will be false only if both the propositions are false. And implication, x implication y. If x, then y. So if x is true, y should also be true. Here y is true, hence the implication will result in a truth value. Here x is true, so y should also be true, but y is false, so which result in a false value for x implies y. And here x is false, so y can either be true or false. The condition for implication is if x, then y, but here x is false, so y can be true or false. So this will result in a true value for x implies y. And the other one is bidirectional equivalence, x bidirectional y. It will be true if and only if y is also true. So for both the values, if it is same, x and y are same, true and true, similarly false and false, it will yield truth value. Otherwise, it will be false. Next is tautology. Based on these operations, that is the conjunction, disjunction, implication and bidirectional, some kind of inference rules can be formed. These rules will produce some propositions, always true, irrespective of the truth values of the proposition. If the proposition is always true, then it is known as tautology. Let us see this by taking one example. I have two propositions P and Q, and the operations performed on it is P implies Q or Q implies P. So let us define the truth table for this proposition. We had taken the two propositions P and Q, and the combinations can be true and true, true and false, false and true, and false and false. So the first proposition is P implies Q, that we have written over here. P implies Q. So implies means if x, then y. So if P, then Q. If it is true and true, it will be true. If it is true and false, it will go for a false. And if it is false and true, false and false, it will be true over here. Similarly, find out Q implies P. The next term in the proposition, Q implies P. So we have to check like if Q, then P. So Q and P. It is true, again true. So it will be true over here. And the other term is false. If Q is false, P can be true or false. Both will result in a truth value. And the other one is Q is true. So P must be true. But here P is false. So it will result in a false value. The other is Q is false. So P can be false or true. Any value will result in a truth. So we got the values for P implies Q and Q implies P. Now we have to perform this disjunction operation. Okay. So true and true, it will be true. False and true will be true. True and false will be true. True and true will be true. So irrespective of the values for P and Q, for this particular proposition, we got the result, all the values as true. So we can say this particular proposition is a tautology. This is called tautology. Next is truth values. So we are going to say that the truth value of propositions are allowed to range in a unit interval 0, 1. Similarly, the truth value in fuzzy logic, very true, can be interpreted as a fuzzy set again in the values of closed interval 0, 1. The truth value of proposition Z is A, or the truth value of A is defined by a point in 0, 1 called the numeric truth value, or a fuzzy set in 0, 1. So in the fuzzy set, it will be linguistic truth value. The truth value of a proposition can be obtained from the logic operations of other propositions. Okay, logic operation means implication, bidirectional, conjunction and disjunction of other proposition whose truth values are known. Okay, so the basic operations are intersection, which yields the minimum of the two truth values. Union will take the maximum among the two truth value. Complement is the negation of a particular truth value, that is 1 minus truth value of x. And implication is the maximum among the negation of x, that is 1 minus truth value of x, and the minimum among the truth value of x, truth value of y. First we will find the minimum from this, and 1 minus tv of x, and we'll take the maximum. That is the result of implication of truth value of x implies y. Thank you.